Hello, Pavel Krupala here from blenderfreak.com and welcome to the part number 19, where are we going to implement the history stack itself. In case you haven't seen the previous video about the explanation how we will actually do that or how the history stack works, I strongly suggest you to go back and check out the video. Otherwise, let's get digging. Okay, so we can start implementing the scene history logic, and we will not mess up with the scene itself. We will create a new file and new class for that, and we are going to call the file, for example, node scene underscore history, and the class name is gonna be scene history. We will override the constructor because we do wanna pass the reference to the scene. So we are going to store the reference, so self.scene equals to scene, and we can basically start implementing the history stack itself. So let's say self history stack, that's gonna be a list. Then we need the pointer, and we are going to call that self history current step, and by default that's gonna be -1, and we are also going to add self.history underscore limit, and when it starts it's gonna be 8. Then we are going to define functions undo, and if debug is on we are going to print undo. We are going to define redo, so if debug is on we are going to print redo. So let's go ahead and define the debug. It's gonna be true for now. What can we do next? We can create new function for storing the history and restoring the history itself. So restore history, and for now we are going to, if debug, print restoring history with current step that is equal to self.history current step, like this, and then we can print out the length. Like this, and that's gonna be length of the self.history stack. We can basically call self restore history stamp and pass in the stamp, which in our case should be always self history stack at, and the item at position self.history current step. Yes, that should be enough, I believe. So we can define the restore history stamp, history stamp, if debug, print I don't know, history stamp, like this. Okay, then we need to store our history, and if debug, print. I will basically copy these two lines and rename that to storing history with some kind of a current step, and then we are going to create a history stamp. So that's self create history stamp with some kind of a description, which we are going to pass inside of the store history. So let's define the function first. That's gonna be create history stamp and we are passing the description, and for now we will return the description itself only, nothing special. Okay, and undo and redo and store history and restore history. So it's about time we start debugging and testing our code itself. So basically what we are going to do is we will go to the graphic view, which is here, to the keypress event, and inside of here we are going to hook up a few keys to test with our debugging. So else if event.key is equal to qt.key_1, then we are going to call self grScene.scene.history, and we don't have the history set yet because we need to go, let's copy this name here, we need to go to the scene and from node_scene history import scene history, and after we initialize everything we can say self history equals to scene history and pass the reference to the scene, so that's gonna be self, and we shouldn't need this scene file anymore. So let's go back to the graphic view. So inside of the history we can store, and I believe the function is being called store history. So store history, and let's say item A. I will copy this because we will attach key number 2 and 3 to be item B and C. So when we press 1, 2 and 3 we are storing the history. Let's call it item A and B and C for now. What do we wanna do next? We do definitely wanna hook up do undo and redo. So that can be, for example, key 4 and key 5. So history, undo, history, redo. And what else? We can hook up another key. So event key is gonna equal to qt key_h, like history, and we can print out the whole history stack on the screen or the console. So history.history_stack, that's gonna be our object, and I would like to just print history with length, and that's gonna be length of this one. I will copy that and I will put comma here because we will also print out current step, and that's gonna be this self grScene history current step. And I guess this could be it, maybe not. We are going to print out the history stack itself. So let's test it out. When I press H, you can see the length is 0 and current step is -1. Okay, so this one works. When I press 1, storing history, current step is -1 and 0, and the history is empty. So that's because we didn't written any other function yet. So let's try it again if actually everything works. Storing history, and we don't know what we are actually storing, so that's not what I want. I do want to see what we are storing. Storing history, Okay, so let's add something here. Okay, and we can type it like this one. So self, no, not self, but description. And restoring history. We can go ahead and add this here. Current step, description. Or not. We will not write it in restore history. So let's try that. One, storing history item A, item A, item A, item B, item C. When I do 4, that's undo, 5 is redo, and H is writing out the history. Okay, so the debugging works. This will be really helpful once we start writing the code. So, basically, we can start from the beginning. First off, we said that when we are storing history, we will basically append, so self history stack dot append the history stamp itself, which is like this. Then we need to increment our history current step, so plus equals 1, and for now we can print out the debug that we are actually setting step to self.history current step. So we can test out where we are actually pointing. So when I press 1, we are storing history item A, current step is -1, length 0, and we are setting step to 0. So when I print out the history, it's item A, length 1, and current step is 0. So now I can press 2, we are storing item B, we started here, and we set our step to be 1. Let's check out the history stack, and you can see we got A and B, length 2, and current step is 1. So what happens if I press many times A, we are setting step up to 17, so basically when I press H, the length is outside of our boundaries. So first we are going to fix the boundaries of the history stack itself, and we can do that here. So the first case we need to take care of is if the history is outside of the limits. So if self.history current step plus 1 is bigger or equal to self.history limit, then we will do some magic. And the magic was we will remove the oldest item, so the first one in the stack, and therefore the size of the history will be decreased by 1. And because we got here our incrementation of the history current step, we will just decrease the history step inside of this condition. So to remove the first element, so self history stack is equal to self history stack starting bit index 1 and not 0 but 1 up to the end of the list will return the whole list except the first item. So this one is solved, and we can trick the counter and say that the self history current step is minus equal 1. So that means we will actually decrease the pointer by 1, but it doesn't matter because we are increasing it here again up to the 7. So now when I press Shift 10 and I press 1 and 2 and print out the history, we got item A and B, so that's 2 items, and we can put another 6 items, so 1, 2, 3, 4, 5, 6. Now when I press, you can see we got length of 8 and current step is 7, and we got A and B, 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 B. So now when I press number 3, we will insert item C, current step is 7, length 8, and setting step to 7. And when I print out the whole history stack, you can see we are currently at step 7, length 8, we are having a B here, and here is the C. The A is missing, so that means that the whole item B stuff was shift and the item C was added. So when I press C 3 times and print out the history, we should see 4 items B and 4 items C. So let's check that. Item B, okay, and item C. So this one actually works, which is awesome. Okay, now we can maybe jump to the undo logic. So when we press undo, what's going to happen? We are going to basically say self history current step and decrease it by 1, and we are going to restore our history. Restore history takes the current step in the stack and tries to restore that. And this should print out what's going on. So basically we can try to run the application, press 1 and 2. So in our history there's item A and B. B is the operation we just did, and when I press undo, that's number 4, we are restoring history and the current step is 0, length is 2, and we are restoring item A. So this one works correctly until we press undo again, because now we are currently at step -1, and in Python when you start indexing the array with minus values, you are going back from the end of the array or the list to the items. So that's the reason why we are seeing item B and not some kind of value error or crash. Okay, that means we do need to add a condition here. So we are going to decrease the pointer and restore the history only if self.history current step is bigger than 0. So let's try that. And maybe before we test it out, I will go just to the left mouse button press, which is here, and I will comment out this debug because we don't need to see that. Okay, so now I press play. I will store 2 operations inside of the history stack, so I will press 1 and 2. You can see there are 2 operations. Currently we are here, and when I do undo, we are restoring history to item A, and if I do undo again, you can see nothing's changing. So now our history is current step is here 0 and the length is 2, so this one actually works, which is awesome. What's going to happen if I try to add item C now? Item C setting step to 1 and the length was 2. Let's print it out, and the history has item A, B and C, and the current step is 1, which is here. So this one is not correct because item B shouldn't be here at all. Therefore we need to go to storing our history and check out for the other condition we were talking about. And the condition is if the pointer, which is called history current step, is not at the end of history stack. So we are going to detect it quite easily. So if self.historyCurrentStep plus 1 is less than length self.historyStack, then what we are going to do, we need to remove everything what is behind the current history step. So self.historyStack is gonna equal to a list starting from 0 up to the self.historyCurrentStep plus 1. And this should basically fix our problem. So let's try that. 1, 2, I will print it out, I will do undo, that's 4. We are currently at step 0, which is here, and when I press 3, inserting item C and do the history print out, we can see we got item A and C, which is awesome. So let's try that. I will press a lot of numbers and press H, and we got A, B, C, whatever, and still the length is 8, so this one works, which is awesome. So our undo should be done, and to finish our redo should be self.history_current_step plus equals 1, and we can restore our history like this. When are we going to restore our history? We were basically talking about that we need to have something inside the history. So basically the condition can be if history current step plus 1 is less than the length of self.history stack, which is exactly the same condition we actually wrote a minute ago, then and only then we are going to redo. So now I can press play. I will press 1, 2, 3. So I inserted A, B, C inside. I will do undo 2 times. So we are at current step 0, that's item A. And now I can test the key 5. And I'm restoring item B. Now I'm restoring item C, which is correct. And if I press more times redo, you can see we are not able to restore anything else. So let's try to fill up it with all A's. If it tests on the edge, redo is doing nothing. I will insert 2 times B, and we got 6 times A and 2 times B. I will do undo, which should lead me here to the B, and now I should be able to see A, and I do, which is awesome. And when I press redo, I should be able to see item B and item B. So item B, item B, and now I'm at the end, so I shouldn't be seeing anything else. So this one works, which is awesome. So basically we successfully implemented the whole logic of the undo redo history stack. Thank you for watching, and see you at the next part, where we are going to create and finish these creating history stamps and restoring history stamps to the whole scene itself.